Hello students, welcome back. The question is from GATE 2006 exam and this one is for 2 marks. Just read the statement, then I'll be explaining it. A router has two full duplex Ethernet interfaces, each operating at 100 megabits per second. Ethernet frames are at least 84 bytes long, including the preamble and the interpacket gap. The maximum packet processing time at the router for wire speed forwarding to be possible is. Okay, so they're talking about something called wire speed forwarding. Let me first explain this. Suppose if you have a router, wire speed forwarding means the rate at which packets are incoming must be equal to the rate at which packets are outgoing. Okay, so this bandwidth must be equal to this bandwidth. In simple words, wire speed forwarding means packets must not accumulate on this router's buffer memory over time. Okay, so there must not be any backlog packets. Okay, that also means in buffer memory of this router, you can have maximum one packet that is currently being processed. That's it. Okay. Now have a look. If you're saying that this bandwidth must be equal to this bandwidth, this also means transmission time will be equal to receiving time. What is transmission time? The time required by the router to put the packet onto this channel. What is receiving time? The time required by the router to get a packet from the channel. Okay. This is length of packet divided by bandwidth. This is also length of packet divided by bandwidth. Length of packet is same for both of these because anyways the packet that is incoming, that packet will only be sent. Okay. So length of packet is same. And we are saying that for wire speed forwarding or wire speed transfer, you need bandwidth to be equal. So TT will be equal to TR. Okay. Let us find out any one of these two. Now they are saying that there are two Ethernet interfaces, both are full duplex. That means data can be incoming at 100 Mbps and at the same time you can output data at this speed only. Okay. What is the meaning of full duplex? Full duplex link is the link at which data can travel in both sides at the same time. Okay, so these two interfaces are full duplex. Now have a look. The packet size is 84 bytes. That means 84 into 8 bits. Bandwidth is 100 Mbps. That means 100 into 10 raised to the power 6 bits per second. Okay, per second will become seconds. Bits and bits will get cancelled. Second upon 10 raised to the power 6. This is 1 microsecond. Okay. So let me write it. You have these many microseconds. Now 84 into 8. 8 fours are 32. 8 8 is 64 plus 3. 64 plus 3 is 67. So 84 into 8 is 672. Divided by 100 will be 6.72. Okay. And microsecond is written as it is. So this means from this interface or from this channel, router requires this much time to receive a packet. I have found out the receiving time. Okay. From this channel, router will take 6.72 microseconds to receive a packet at 100 Mbps if packet is of 84 bytes. Okay, something similar will happen here also because all the numbers are same. So here also you require 6.72 microseconds to receive a packet. Now have a look. Wire speed forwarding means you must transmit the packet in this much time only, right? We are required to find out the processing time. That means if you want to maintain both of these times equal, then what is the maximum time that you can allot for processing one packet? This is what we are required to find out. Let us have a look. See, at time t is equal to 0, suppose from both of these interfaces, you are getting incoming packets. How much time will it take? 6.72 seconds. Okay, I'm using seconds here, but it is actually microseconds. 6.72 microseconds. In this much time, you will have two packets. One packet from this interface and one packet from this interface. Both of these packets will be in the buffer memory of the router. Okay. So after this much time, you have received two packets. Receive packet 1 and packet 2. Okay. What will happen in next slot of 6.72 seconds? The data is constantly incoming. Okay. So in next 6.72 seconds means 6.72 plus 6.72. This much time. At this time, you will receive packet 3 and packet 4 also. Okay. Now have a look. At this point of time, two packets were completely received and they were present in the buffer memory at this point of time. Okay. During this time, we were receiving them. But here the packets are in buffer memory. Similarly, here what will happen? Here two new packets will come in the buffer memory. But we don't want to accumulate the packets. That means the two packets that were received initially, they were received here. By this time, at this point of time, you must start transmitting them because you don't want to accumulate data. That is what I initially told you, that this rate must be equal to this rate. This can only happen if you don't accumulate packets. At maximum, only one packet can be there in the router. Okay. For this case, it is two packets because one from this interface and one from this interface. You'll have these two packets lying in the buffer memory for this much time. Okay. At this time, you will get two new packets from both of the interface, and the packets that are currently lying here must be transmitted. So transmit packet 1 and 2, and at the same time you will receive data also. Okay, so packet 5 and 6 will be received during this time. That means after 6.72 plus 6.72 plus 6.72 seconds, at this time you will get two more packets. So these packets have to be transmitted here. So how much time, for how much maximum time can a packet lie in this buffer memory? That is, two packets can lie for one slot. One slot is of 6.72 seconds. So two packets can lie for 6.72 microseconds. Okay. For this much time, you can process two packets. They were asking about one packet. So one packet can be processed for maximum of 3.36 seconds. Okay. Half of this value. So 3.36 microseconds is the answer to this question. If you haven't still understood it, let me explain it in one more way. Suppose at time t, at some time, you are having two incoming packets from both of the interfaces. You are having two outgoing packets from both of the interfaces, and two packets are currently in the memory. Okay. So here you have two packets. Suppose the receiving of this packet has just now started and you have just now started transmitting a packet. The receiving will take 6.72 microseconds. Here also transmission will take 6.72 microseconds. Okay. Now, starting from the time when the transmission just begun, you can spend this much time in transmitting a packet. After this much time, you need to start transmitting both of these packets, right? Because if you don't do so, if you give some delay, these two packets will also come in the buffer memory and packets will start accumulating. We don't want such a scenario. So after 6.72 seconds, you must transmit these two packets. So these two packets can lie in the buffer memory only for this much time. That means you can process the packets for this much time maximum. Okay. So two packets can be processed for this much time. One packet can be processed for this time divided by 2. Okay. So this is the answer. I hope you understood it. Thank you very much for watching this video.